Okay, let's have a look at sand and the fluid one. A lot of the settings are obviously similar to what we were looking at with snow. Sand is almost exactly the same, apart from it doesn't have any of that initial hardness or firmness. So let's have a quick look at some of the things. So we've got this cohesion, and this is how much it wants to stick together. So at 1, sticks together, no. And at 0, almost exactly the same. If I crank that to something like 10, let's do 100 just to see if it works. Yeah, so at 100 it does, but this is also linked to this volume preservation. So if I do this, I think it's to 1, and hit rewind and play. See, it just ignores that and goes to sort of spreading around. And that's because of this preservation, volume preservation over shape preservation. So let's just double check that one more time. So 0, 1 means shape preservation, no shape preservation at all. It behaves like a liquid. So it will sort of ignore this cohesion. But if you put it at 0, it will just boink like a ball, boink, with tiny little bit of thingy. So that's the only sort of difference there. Everything else is sort of the same. Obviously we've got viscosity and things like that, which we've done before. Let's have a look at the fluid. So I'm just going to turn off sand for the time being, turn on fluid. Maybe over here. I have to rewind probably. There we go. And I'll just make these a little bit smaller. Let's do 64 of them. So, different things we've got here. We've got surface tension and Viscoelasticity. So, we're not really going to see surface tension if I change that setting, because it's how droplets are made. The more the higher the surface tension, the more likely it is to make drops when it splashes. You need quite a high res sim to sort of even begin to see that sort of stuff. So I'm not going to sort of show that parameter, just to double check that I'm correct there. Yeah, so how much liquid tries to shrink the overall surface size. This is what causes fluid to bead into droplets. So we won't see that one unless we really cranked up the thingy, and it will take ages to sim. This viscosity's got this going on, which when I first opened this up and sort of looked at that, I went, I have no idea what that is. So I had to Google it. Hang on, let's minimise that. Do this. So if you just type that in there, you get this. So what this is to do with the limitation of Maya. Maya can't show more than 3 decimal points. It can take in information more than 3 decimal points, but it can't show it. So if I went to, say the pit mesh, and just went to my attribute editor, you see it's like 1.000. Doesn't show any more than that. If I put a 1 there, it will just go back to 0. That 1 is actually there, it just won't show it. Which always thought was a bit weird, and I don't know why they changed it. They must have some sort of internal reason why they don't. So this is the way around it. This is basically saying 0.00001. So so this is the power of, as it basically, but as a decimal. So it's got to sort of 6 decimal points, or 5 decimal points, but 6 including the first one. So 1, 2, 3, 4, 5, 6. So yeah, I don't know why I did that. So if I change this to 5, nothing happens, but that's now 0.0001. If I change that to 4, it shows it. So in here you can actually see to 4 decimal points, but outside here you can't. So if I then put that back to that, and it goes like to that, and if I change this to a larger number like 5, and take that back to 4. We're changing that there to 0.5. So what you're sort of seeing there is that's the value, and that's how many decimal points is it. And sort of clear that up. And what else we got? We've got Viscoelasticity. How does that work? That is basically how much the fluid tries to remember its original shape. So let's just crank that up to 100 or something, to see if we can get it to work. When we do that, we get that. So you get sort of jelly-like boink. It's quite nice, isn't it? And the relaxation time is how quickly, I think, it will try to revert to its original shape. So let's have a look at that, just double check that. How quickly, so when 0, the material forgets its deformation immediately, creating a more viscous behaviour. Larger values will become more elasticity. Values are in seconds. So let's just try that at 0 and see what happens. I'll rewind. Oops. See, it's not even moving. Let's try that at 1. Hit play. No, so you put that at 0, it's... Let's try that. So let's try that at 100 again and see what we get. So can't really tell it, but it's a speed thing. It's how much quickly it will try to. So that's fluids and sand. We'll look at cloth separately.